This is Richard with JR T44, and this is the fifth in a series of videos regarding how to set up a new helicopter model in the JR T44 transmitter using the JR Tags Mini 3-axis flybarless gyro system. In the last video, we confirmed that the throttle and pitch curves were controlled by the flight mode switch. We set up a throttle hold switch, and we set up a stick-activated countdown timer. In this video, we're going to set up 3 different sample throttle curves. One curve for use in normal mode, a flat curve for use with ESCs with internal governors, and a smooth curve for use with ESCs and flybarless units without internal governors or when a governor is not desired. The first thing we're going to do is set up a curve for use in normal mode. And normal mode is usually used just during takeoff and landing. We're going to set this curve up assuming that we do not have a governor in use. We start by turning on the transmitter, and from the home screen we're going to press the L button to take us to the function list. Once in the function list, we're going to go into the throttle curve menu. We highlight throttle curve and click the roller. Once again, we're at the all servos hold screen, and we've seen this before. We haven't really discussed it. This is a safety feature. So if you're at the field, you're changing your throttle curve, your pitch curve, your gyro sensitivity, this menu will always show up, allowing you to say, yes, I want all the servos to hold, so that you can't accidentally have the motor start, flip the helicopter over, have some other kind of problem. So this is a very useful thing. Normally, I just hit yes to make sure all the servos hold. If I'm on the bench working on a helicopter setup, I would have to hit no in order to move the servos to the helicopter setup. So I'm going to hit yes now. Now we're in the throttle curve menu. Now, we can see on the left, we saw the last video where it says norm. I flip the flight mode switch, and I go from normal to stunt 1 to stunt 2 and back again. So just a general look at this screen. We've got a table over here on the right that tells us what the input and output settings are for the throttle stick at its lower position, position low, its middle position, position 1, and its top position, position high. Now in the T44, I can actually put 7 points in this curve. I've got 3 now, the L, 1, and the H. But I can go up to 7 if I need to. If you're in competition, you're trying to get something very precisely set up, the radio is capable of doing that. For our purposes, which are sport flying, we're just going to stick with the default of 3 points. Now, normal mode again is really only ever used during takeoff and landing. If we keep a linear 0, 50 to 100% throttle curve, we're not going to have enough RPM at takeoff in most cases for the helicopter to be stable and have adequate control. So we're going to raise this center point, point number 1, in the throttle curve. To do this, we scroll to the right to the center position, position 1, output, and we're going to click the roller. Now normally someplace between 65, 70, 80% is good here. We're going to roll this up to 70 just for a starting point. Now right now we have a throttle curve with a sharp bend in the middle. We really don't want that. We want a nice, smooth power curve. So if you look at the bottom center of the screen, you'll see the word or the acronym EXP, that's for Expo, and below it is the word off. Now this isn't really Expo as we're used to using, but what it's going to do when we invoke it, it's going to change this curve from a curve with a sharp bend in it to a nice, smooth curve. So we scroll down to Expo off, highlight off, click the roller, and now we have a smooth curve. When we go to test fly our helicopter, if we lift it off the pad and we don't have quite enough RPM, then we scroll back up to our center position, where we have 70 set. Click the roller, add a few more percentage points of throttle, click the roller, and then go back and test fly again. Likewise, if the helicopter tends to overspeed at liftoff, we can scroll this down again and bring it back down to a lower number. Now, if you look to the right of center on the curve, you'll see that it goes all the way up to 100%. I've seen a lot of people truncate this and have it go flat pretty much to the right of center. You don't really want to do that, because as you continue adding, increasing your throttle stick and increasing your collective pitch, your throttle will then stay at one fixed setting. Your collective pitch and the drag induced from the collective pitch will increase, and you'll lose RPM. So even though this is really just a takeoff and landing flight mode, we want to make sure we have that good constant RPM so we have full control and full stability of the helicopter at all times. And again, these are sample values right now, so these will change in testing, and we'll get into that a little more later on. The next thing we're going to do is we're going to set up a flat curve for use with governors for our Stunt 1 mode. We go into Stunt 1, and you see we've gone back to the default 0, 50, 100% curve. We're going to want to change this so that it's flat all the way across. We're going to set 60% as an arbitrary value just for purposes of this exercise. We're going to scroll to position low out, our low throttle stick position, where it says 0 now. Click the roller, and we're going to scroll to the right until we raise this to 60%. And again, 60 is selected, it's arbitrary. It'll vary depending on your ESC, your helicopter, etc. So it's just arbitrary for points of this exercise. Bring this up to 60%. We now have a kind of oddly shaped V curve. We're going to scroll down to position 1, our center position, highlight the output at 50%, scroll it up to 60, click the roller, and then we're going to scroll to our high position, which is still at 100%. We're going to click the roller. We're going to bring that back down to 60, and that will result in a perfectly flat curve. Now, we didn't activate Expo this time because we have a straight line. There's no curve with a knee in it to straighten out, so we don't need to do that. The next curve we're going to do is going to be a nice smooth curve for aerobatic flying, and this would be used if we don't have a governor of any kind. So we go into Stunt Mode 2, and again we have the default 0, 50, 100% curve. We're going to scroll up to position low for our throttle stick, click the roller, and we're going to bring this up to 100% so that it matches the position high throttle setting. Lot of scrolling here. Sorry, this is boring. Lots of scrolling. Okay, now we're up to 100%. Now we have a sharp knee in the curve, at the bottom of the curve. We don't want that. We're going to scroll to our second position, and just for, based on experience and sort of rule of thumb, we're going to bring this up to about 80%. And it'll vary from helicopter to helicopter. It'll vary with blades, etc. So that around 0 pitch, we'll have 80% throttle. If we increase the throttle stick, we'll go to 100%. If we decrease the throttle stick below half, which is below 0 pitch, it'll also go back up to 100%. The intention of this is to have some semblance of constant RPM without a governor. Now, if you notice, we've got the sharp knee in the curve again. So we're going to scroll down to where it says EXP. We're going to highlight off. We're going to click the roller, and now we have a nice smooth curve. Now, from a practical standpoint, we're out test flying our helicopter, we have it up in a hover, and let's say the RPM is a little too low for where we want it in the hover. So we'll land the helicopter, we'll go back into this menu, we'll scroll over to 80, click the roller, bring the center of the curve up a little bit, and then repeat the test flight. If the helicopter is overspeeding its center, we can bring it down a little bit. Likewise, we can't go above 100% at the extremes of the curve. We can lower them a little bit if we have overspeeding. Now, again, this is all done with a 3-point curve. We didn't need to put all 7 in. We could if we'd wanted to, but for the sake of simplicity, this works really, really well. In the next video, we're going to have a similar discussion about collective pitch curves. Thank you.